Okay, we're going to look at solving absolute value equations and inequalities. Now, when you're solving either equations or inequalities, with either one, whichever you're doing, you're going to have two solutions. Therefore, you must write two equations or inequalities. Okay, an example with an equation. Absolute value of x minus 6 equals 8. Write one equation exactly as it is without the absolute value bars there. X minus 6 equals 8. And another one the same, but the right side is negative. X minus 6 equals negative 8. And then just solve each of these. Add 6, add 6. X equals 14. Add 6, add 6. X equals negative 2. So you would have two solutions to this. We'll go by 5s to make it a little bit reasonable to draw. Okay, one solution is at 14, so it's just a mark at 14, and one solution is at negative 2. So we have two values that are solutions. And if we plug these in, 14 minus 6 equals positive 8. The absolute value of positive 8 equals 8. If we put in negative 2, negative 2 minus 6 equals negative 8. And the absolute value of negative 8 is positive 8. So those would be the two solutions. We don't have to graph the other one, but we'll work through to make sure you have it down pat. The absolute value of 2x minus 9 equals 15. Write the 1 exactly as it is. And write the other one the same, 2x minus 9, but make this negative 15. Let's solve these. Add 9, add 9. 2x equals 24. Divide by 2, divide by 2. X equals 12. Go over to the other side. Add 9, add 9. So we have 2x equals negative 6. Divide by 2, divide by 2. X equals negative 3. And those would be your two solutions. Again, you could plug them into this original absolute value equation, and you would find that both of those are true. Okay, moving on to inequalities. Again, with inequalities, you must write two inequalities. First one, as it is here without the absolute value bars, and the second one with a negative, but also flip the inequality sign. So we have x is greater than 3 and x is less than negative 3. Okay, to graph this, x is greater than 3. Or x is less than negative 3. Now, make a little note here. The greater than problems, or the absolute value greater than problems, are OR inequalities, where only one of them has to be true. So here would be an example of an OR problem, just as we learned how to graph those in the last section. Write 1 exactly as it is. 2x plus 8 is greater than or equal to 12. Write another one, but flip the sign and make it negative 12. Okay, we'll go ahead and isolate x, subtract 8, subtract 8, divide by 2, and x is less than or equal to negative 20. Excuse me, negative 10. And doing this one, minus 8, minus 8. 2x is greater than or equal to 4. Divide by 2, divide by 2. And we have x is greater than or equal to 2, or x is less than or equal to negative 10. Do a quick approximate graph on this. Again, being an OR problem, how you learned how to graph those the last section. Greater than or equal to 2, or less than or equal to negative 10. So any value in these shaded areas, everything from negative 2 up, or excuse me, positive 2 up or negative 10 down, will be true if you plug it in to the absolute value equation. If you picked a number that's not shaded, like negative 5, it will not be true. Okay, if you have a less than problem, these are AND problems. And I'll go ahead and rewrite this one over here. X plus 6 is less than 2. And x plus 6 is greater than negative 2. Subtract 6. X is less than negative 4. Subtract 6. X is greater than negative 8. Now, because this is an AND problem, they must both be true. Okay, the graph of x is less than negative 4 would be that. X is greater than negative 8 would be that, because it's an AND problem, as we discussed in the last section. It's where they overlap. So we shade the area where both are true, and the numbers between negative 4 and negative 8 will be true if you plug them into this absolute value equation. If you picked a number over here, or a number more negative than 8, it would not work. For example, if you plugged in 0, 0 plus 6 is 6. The absolute value of 6 is not less than 2. So that's showing you the point outside the shaded area and does not work. So again, in summary, with inequalities, if it's a greater than or equal to, it is an OR problem, as you learned how to graph that in the last section. If it is a less than or equal to, it is an AND problem. And that's it for absolute value, equations and inequalities, and how to graph them.